the AI industry is hurtling towards an unprecedented energy crisis. In 2024 alone, AI systems and data centers devoured 415 terawatt hours of power, a shocking 10% of total U.S. electricity production. This isn't just a number, it's an unsustainable path, with energy demand from AI projected to double by 2030, soaring to an estimated 945 terawatt hours. We are teetering on the edge of a global power deficit, and most don't even see it coming. Think about what 415 terawatt hours actually means for your life. It's not just abstract data center costs, it translates to higher electricity bills for everyone, increased carbon emissions impacting our planet, and a looming bottleneck for technological progress. Data centers alone consumed 4.4% of U.S. electricity in 2023, a figure that could triple by 2028 if we continue on this trajectory. This isn't just a tech problem, it's an existential one for our grids and our wallets. Conventional AI models are the culprits. They are resource-hungry black boxes, brute-forcing solutions, and consuming vast amounts of energy in the process. While they excel at certain tasks, their inherent inefficiency creates an enormous, unsustainable environmental and economic footprint. The current approach is simply not scalable for the AI-driven future we envision. It's like trying to fuel a rocket with a garden hose, it simply won't work. But what if I told you there's a radical alternative, a neuro-symbolic AI approach that shatters this paradigm? Developed by researchers, this new system combines the power of neural networks with the logic of symbolic reasoning, mimicking how the human brain truly solves complex problems. It's not just a tweak, it's a fundamental rethinking of AI architecture that promises to solve the looming energy crisis. The numbers are astounding. This neuro-symbolic AI cuts energy consumption by a staggering 100 times compared to traditional models. Let that sink in, 100x. To put it in perspective, the energy consumed by a median Gemini app's text prompt is now equivalent to watching television for less than 9 seconds. Imagine scaling that efficiency across global AI operations. This isn't just an improvement, it's a revolution in power usage. The efficiency gains are paired with unprecedented performance. While conventional systems fail 2/3 of the time on complex tasks, this neuro-symbolic approach achieves an incredible 95% success rate. It's not sacrificing accuracy for efficiency, it's delivering both, proving that smarter AI doesn't have to mean hungrier AI. This capability gap is precisely why the traditional path is doomed. But here's where it gets really interesting. While the industry panics about AI's insatiable power demands, the data suggests the solution is already emerging, just not where most are looking. Google, a titan in AI, is already making significant strides, even with its existing infrastructure. In 2024, they reduced data center energy emissions by 12%, a remarkable feat given a simultaneous 27% year-over-year increase in electricity consumption. But this is just the beginning. The true game changer was revealed in April 2026. Breakthrough research from Tufts University demonstrated that neuro-symbolic AI uses just 1% of the training energy and 5% of the execution energy compared to standard VLA models. This isn't a marginal gain, it's a verifiable 100x efficiency improvement specifically on structured tasks. This data point, largely overlooked, is the real blueprint for sustainable AI. Consider the implications of this Tufts research. If widely adopted, AI's projected 945 TWh demand by 2030 could be drastically reined in, potentially slashing future consumption by orders of magnitude. This isn't theoretical, it's hard data indicating a path to dramatically reduce our reliance on new power plants and curb the environmental cost of AI. This is the future we desperately need, backed by verifiable science. We've already seen this efficiency in action. Over a 12-month period, Google's Gemini app saw median energy consumption and carbon footprint per text prompt decrease by factors of 33x and 44x respectively. This isn't just lab bench theory, it's real-world deployment delivering massive, measurable sustainability gains right now. The technology is here, and it's proving its worth in production environments. The shift to neuro-symbolic AI isn't confined to text prompts. The potential impact spans entire industries. Imagine electric vehicles with vastly extended ranges because their AI systems are 100 times more efficient. Or smart cities that manage resources with a fraction of the energy. The International Energy Agency, IEA, estimated AI could reduce global energy consumption by 10% by 2030. With neuro-symbolic AI, that figure becomes a conservative underestimate. Here's the hidden truth: while companies boast about incremental efficiency gains, the underlying architecture often remains unchanged, leading to a relentless pursuit of more power. The IBM Institute for Business Value notes AI can reduce data center energy by up to 30%. That's good, but it's still fundamentally patching a leaky boat. Neuro-symbolic AI isn't patching, it's building a new, unsinkable ship. This is the contrarian view: we don't need more power, we need smarter power. The real twist? Despite this overwhelming evidence and the clear, urgent need, many in the enterprise AI market are still chasing traditional, energy-intensive solutions. The market was valued at $114.87 billion in 2026, projected to swell to $273 billion by 2031, yet the widespread adoption of radically efficient neuro-symbolic methods remains shockingly slow. This is a massive market missing a crucial opportunity, clinging to outdated paradigms. Why the hesitation? Change is hard, and the inertia of massive investments in traditional AI infrastructure is powerful. Companies are trapped in a cycle of marginal improvements, fearing the disruption a true 100x efficiency leap would bring. But ignoring this innovation means not only escalating energy costs but also falling behind competitors who embrace sustainable, high-performing AI. This isn't just about being green, it's about competitive survival. So, what's the actionable takeaway for you? If you're building AI systems, developing products, or investing in the tech sector, demand neuro-symbolic capabilities. Look beyond superficial green marketing and scrutinize the actual energy footprints. The Tufts research, coupled with real-world Google examples, proves that a 100x reduction in energy consumption is not a fantasy, it's a proven reality. This is where innovation truly lies. Embracing this paradigm shift means not only a sustainable future but also superior performance. The 95% success rate on complex tasks where conventional systems stumble provides a clear competitive edge. This isn't a trade-off, it's a win-win. By focusing on smart, efficient AI architectures, we can avert the looming energy crisis and unlock unprecedented capabilities for innovation and growth. It's time to stop fueling the problem and start building the solution. This isn't just about reducing energy, it's about pioneering the next generation of truly intelligent, responsible AI. The choice is stark: continue down the path of unsustainable power demands, or embrace the neuro-symbolic revolution. The companies and individuals who understand this fundamental shift will not only save billions in energy costs but will also define the future of technology. What will you choose?